Alright, Common Core Algebra 1, Common Core Algebra 2, sorry. Next flip lesson, this is going to be the start of Chapter 3, and Chapter 3 is going to be all about systems of equations, and mostly we're going to look at linear systems of equations. We'll also look at linear systems of inequalities later in the chapter. We're going to look at several different ways to solve systems. I think 4 if my memory serves me right. Today's going to be our first way, and this is going to be with graphing. So when we do graphing, we're going to check to see if a point is a solution. We'll talk about that, and that could be, if anything, not just necessarily graphing. And then we'll show you how to do it with graphing. So just as a quick reminder, we've got 2 lines here, and we're going to graph both these lines. So we've got both of them in, remember, y equals mx plus b form, and our b value 1. So we'd put a point at 1, and then our slope here is -2/1, so we'd go down 2 and right 1, and we'd end up with that red line. In contrast, the other one, we have a y-intercept of -2, so we'd put a point at -2. And since there's no number in front of x, we remember that it is a 1 over a 1. So from -2, we're going to go up 1, right 1, up 1, right 1, keep doing that, and we have our blue line. Now, don't forget that from our y-intercept, we could have gone down 1 and left 1, the opposite of up and right. And just like that on the other one, instead of going down 2 and right 1, we could have gone up 2 and left 1. Either way, we're going to get the same line. So to review a system of linear equations, that's going to be any 2 equations or 2 or more equations with the same variable, or really we should even add to that variables. Now, everything we're going to look at today, and for the start, we're only going to work with 2 variables, x and y, but really we could have any number of variables in our equations. The key there is that for every new variable that we introduce, we need to have an extra equation. So if we have 2 variables, we need 2 equations to solve it. If we have 3 variables, 3 equations to solve it, so on and so forth. The solution to a system is going to be an ordered pair or a point, so like an x and a y value, that make, and here is the key, both equations true. So if it makes one equation true, you're not necessarily found the solution. You need to make sure that it makes both equations true. And in order to check that, so here's our first objective, we're just going to plug in, or a better word would be substitute, the x and y values and test to see if the statement is true. And as a reminder, we don't forget, that needs to be both equations. Okay, so we're going to test that in both equations. Now, we'll come back to this slide actually. So checking a solution, like we said, we're going to plug in our x and our y into both equations and see if the equations are true. And if that is the case, then the point is a solution. If only one is true, it's not a solution. If both are false, obviously it's not a solution. So I've got 2 equations here, and I've got my x and my y value. I'm going to plug those in to my first equation. So my y is 4, and then I've got negative of -3 plus 3. And so this is going to give me 4 equals negative of negative is a positive 3 plus 3, and you see that we get 4 equals 6, which is clearly not a true statement. So this would be not a solution. Okay, I'm going to give you another example here. We can do the point 1, 2. I'm going to plug in then still, I'm going to start with that first equation, 2 for y. I get a negative x, or a -1 now, plus 3, and that gives me 2 equals, combining -1 and 3, 2, which is good. So that's a true statement. So it works in that first equation, but don't forget we need to try it in both equations. So I'm going to plug it into that second equation, 2 for y, and then I'm going to plug in 1 for x, and 1 plus 1 is 2, so that works. So this one is a solution. So you saw one example where it wasn't a solution because we had a false statement. One example where it was a solution because we had 2 true statements. So that's how we check a point to see if it is a solution to a system. We looked at both equations we had. Now, types of systems, we're going to have 3 types. We have consistent, independent, consistent, dependent. The keywords there, you'll hear people talk more about them as independent or dependent systems, and then we also have what are called inconsistent systems. So an independent system is when we have 2 distinct lines and there is 1 point of intersection and therefore 1 solution. So the key there is 1 intersection of those lines, and that gives us 1 solution. We could have what's called a dependent system, which means both of our lines are, we say they're non-distinct, but basically if we're to graph them, you draw your second line right on top of your first line, and so that gives you an infinite amount of solutions. The last one then we have is an inconsistent system, and that's going to be only occurs when we have two parallel lines, and because they're parallel, they never intersect, and therefore no solutions. See, the thing we talked about in all of these had to do with our intersections. One intersection gave us one solution. If we draw one line on top of the second one, really that gives our infinite intersections because they're the exact same line, and therefore infinite solutions. And if it never intersects, no intersections, no solutions. Okay, so the last thing we're going to talk about is how to solve a system by graphing. Really, this isn't going to be anything new for us. We're going to start by just graphing both of our equations. So instead of doing one line, we do both lines on the same grid. And then we find the point of intersection. So there's either going to be, remember, one point of intersection, an infinite amount if you have the same lines, or 0 if the two lines are parallel. And you identify those coordinates. So we want our x and our y coordinates. And finally, as always, it is smart to check your solution by plugging into either or. Really, we probably want to have both equations here. That's probably a better idea. We want to make sure it works in both equations. And so that would be, whoops, here we go. Okay, so last piece, our point of intersection is the point or coordinates where the two lines intersect, and this point of intersection is going to be our solution. So we mentioned in 2 slides ago that we were looking for one point of intersection, and that would be our one solution. There's no point of intersection if they're parallel, or an infinite amount if they are the same line. So real quick here, we've got our red line graphed here, our y-intercept at 3, and we go down one, right one continually because our slope is -1/1. And then the blue line point at 1, and we're going up 1, right 1 because, again, our slope is 1. So we want our point of intersection. That is just where our two lines cross right here, and you see that point of intersection is 1, 2. And we know that's a solution because those are actually the same two lines that we looked at earlier, and this was our point that we tested, and so we already actually checked that. They make both equations true, and therefore that is the solution to our equation. Okay, and that is it for this lesson. So we talked about how to check a point of intersection to see if it is a solution. We just plugged it in. Remember, you absolutely need to do it to both equations. And then we found by graphing, which really was nothing new for us. We just graphed two lines on the same grid, and that gave us our point of intersection if we had one, infinite if it's one line on top of the other, or 0 if they never intersect. I'll see you next time, guys.